Hello. We are starting this unit with objective 5.1 that you use trigonometry to find missing sides and angles. And we're going to start with just a very straightforward problem that you probably remember from geometry. And it has to do with the use of this word, SWBAT, which tells you the three main trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now there's three new ones that I'll write down in a moment, but these are the three important ones. And the first thing you would have to do when looking at this is to determine which side is which. Now the one you should always get right is the hypotenuse. That's the longest side, and it's the one that's across from the right angle. So this is the hypotenuse, and I'm just going to label it here. And I recommend you label it until you're sure that you always get it right. The next one I usually do is the opposite, which is across from the angle we're using. Now notice there's two other angles we could use, but this one just happens to use this one. So that determines that my opposite side is across from that angle, which is 12. And adjacent means next to, so the adjacent side is the one that's next to the angle that we're using, which is 9. This symbol, by the way, is theta, and it's just kind of like an X in the world of trigonometry. So I'm going to write my first three trig identities. First one is sine of theta. You always have to say sine, cosine, or tangent of which angle you're talking about, because again, there's more than one. Sine of theta is equal to opposite over hypotenuse, which is 12 over 15. And if you think that reduces, it does, because these both divide 3, so that is 4 over 5. The SOH in SOHCAHTOA tells us it's opposite over hypotenuse. I'm going to write the other ones now using the other parts of SOHCAHTOA. Cosine of theta is equal to adjacent over hypotenuse, which is 9 over 15. So that reduces to 3/5. And then there's two ways to find tangent. One way is to say tangent is equal to opposite over adjacent, so that is 12 over 9, and that's 4/3. Or the other way to do it is to say the tangent is equal to sine of theta over cosine of theta. And in this case, sine of theta is 4/5, and cosine of theta is 3/5. And you notice that those fifths cancel out. So you end up with 4/3, just the same as we got up here. I don't care which way you do it. They obviously come out to the same answer. Finally, we get to the three new ones. Now, sine, cosine, and tangent each have what's called their reciprocal trig functions. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Now, I'm just going to write each of these. Reciprocal just means that it flips, or you can think of like h over o instead of o over h. Doesn't really matter. So cosecant of theta is the reciprocal of sine, so that's going to be 5/4. Again, I just flipped that fraction. Secant of theta is the reciprocal of cosine, so that's 5/3. And then finally, cotangent of theta is equal to the reciprocal of 4/3, which is 3/4. And you might wonder like why we added these. And just so you know, if you take a look at these three numbers, you could make a total of 6 fractions out of them. This covers all 6 possible ways to make a ratio out of those 3 numbers. So that's why we have these additional 3. It fills it in. There won't be any new ones. This covers everything. So that is it. A pretty basic problem of just writing our trig ratios.